I think we use that one instead. That's good. Alessandro Fanni from Italy. He's CEO and founder of 𝗖ście, and they're working on building and deploying their own constellations of PocketQubes for Internet of Things. So I'll let him take it away.
Thank you. Hi all. Thank you to let me present our new projects and our progress of this year. 𝗖ście is an aerospace and artificial intelligence company. Okay. We start in 2018 as only an IT company. We produced initially an artificial intelligence that is now patented in Europe, called Pongo. And after this great success, we trying to find the limit of this new project, this new invention. So to do that, we, as we mentioned on the other days, we create a solid team distributed in Italy for now, in near Milan, with 2 headquarters in Piacenza and Cremona, and another one in the south, in Cagliari. Now we are opening in Canada, in Montreal, and now we are starting to build in Nottingham a new headquarter. What we want to solve? We want to solve a problem on IoT. So we wanted to work in different scenarios that has no internet, no stable power lines, and with different IoT devices, and without a specific software. To do that, we got a lot of work to do that, of course. And the first one is the first patent was Pongo, as I mentioned, an integrated development environment that is like a complex IoT module with an AI module and a data learning module. But the quality of this tool is this one, Pilot. Pilot is a nano-picosat satellite that can provide a direct-to-satellite low-power wide area network and several other services. And with this very little satellite, now we can say that we are starting to create cubesat. So the title of my speech today is how we can use picosat as a disruptive approach to start to create an even bigger satellite. So after Pilot, we work initially, of course, with indoor application with our lower TRL devices in order to test our gateways in indoor scenarios. After that, we work even on outdoor scenarios and different applications with our satellite that is in orbit from, let's see, from the Transporter-Free mission. After that, even partners was very, very important and crucial to identify the right partnership in order to start a very difficult path that was the auto production of all the subsystems. To do that, we work a lot on PCBs and our firmware and power budget routines, and we won a lot of prizes in Italy and Europe, and this year even in Canada with the CDL program, and even in the Italian chamber. We are focused on social social activities to, let's say, mind and cover the gap with the universities and our secondary schools, where we have the headquarters, of course. Now we are on the right path, because we have established the first 2 data centers in Italy with several installation of Pongo and 3 ground stations. And now we are now serving with an end-to-end approach. So we've designed even the system on chip that is booked at the FCC. So, as I mentioned, the first mission was the transporter free. After that, we've done several missions, because we tested a lot of our subsystem in cubesats and suborbital missions. Pilot, as I mentioned, is a platform that is, like I think the MRC 100, is totally designed internally, and now is granted by ESA and NASA. We are now on different paths with them. We have 2 applications, and now we are a part of the ESA BIC. And as we can see, we started to the modular structure that is ready to scale from 1P to 4P. We designed the OBC and a particular subsystem that is a particle detector that now we are using to detect high-level radiations in orbit to shield the satellites, switch off all the critical subsystems. As you know, a few weeks ago, $30 million of satellite deorbit thanks to a solar winds. So it's quite a problem to shield and protect our assets in orbit. And we reduced this technology to picosat standard, because we know that we have less money than others, and we have to protect our picosat asset in order to not end the mission the second day. After that, we produce even a standardized I/O board that provide a double-checked blockchain and SD card hardware, so as we can keep our data secured by all. And we provide, of course, RF subsystem, IoT-oriented, integrated with optical payload. Now we are working and distributed even multispectral cameras with a low resolution, of course. But the way we achieve results with picosat is quite incredible, because now for us it's more simple to work on cubesats. As I mentioned, all types of RF and radios we are working on, from UHF to Ka band, C band, and now we are working on W band, even on picosat. So we are focused on miniaturization. Why? Because we are very focused on the power budget, and we can spread up our technology in CubeSats standards with multiple, let's say, multiple goals, let's say, and in the same surface of CubeSat, for sure, we can increase 4 times the number of subsystems. Our CubeSat now is designed on the external format factory on CubeSat, and internally is all picosat. So is fundamental for us because we can test and do a lot of IODs in orbit demonstration in a very concentrated volume. Oh, that's it. Okay. Oh, thank you very much, my baby. So this is pilot, and you can see pilot after, but I hands the hands. Sorry. As you can see, we provide a deployable solar system. We are testing even, let's say, different arrays of solar cells. And now we are working on the origami payloads, for example, for cubesats. In a U of volume of cubesat, we can produce 80 watt with our deployable solar systems, and we are working with several startups in Italy to do that. DPS for sure is critical and useful for the ADCS, and the battery. We are not showing off our batteries because we are working on graphene batteries. We have patented, yeah, for sure, graphene is the future. So we are working on that topic with two different universities, sorry, and we have successfully patented a new polymer in USA. And this year, another milestone is the ADCS. We provide all the magnet torquers and reaction wheels directly from our industries. We are working with a partner on thrusters, on the thrusters, but for sure we use our technology to double even the duration of our electron sprite thruster. This is the final version without an antenna, but okay. So you have 5 different radios. Is not, no, sorry, not here. Sorry. Here, okay. We don't have here an antenna, but we are working on S-band gateway here and on the sub-gigahertz gateway. So we have the S-band payload here, and here we have the sub-gigahertz programmable gateway. Here we have the ADCS, here the battery pack, the OBC, the nano CPM, and the I/O board. Here the thruster, and the UHF is directly spread all around the PCB here. This is an earth sensor for the ADCS. Okay. So, as I mentioned, now we have even our system on chip working on S-band and sub-gigahertz. So 𝗖cie HS8 for Europe and other states that are using this LoRa type, and 9.5 in USA, and 2.4 gigahertz for all the world. This is an example of our tracking antenna, and this is the entire network. Now we can say that we have 3 pilots still in orbit because we are hosted inside 3 different CubeSats because we need to test even other subsystems like the Cosmos CPM in the last Cosmos 𝗖𝗰𝗁 mission. This is a particle detector, a bigger particle detector to study cosmic rays in collaboration with our National Institute of Nuclear Physics. And now we have successfully tested even our new deployer in zero gravity. So we established the Sardinian headquarters because there is in Italy there is a aerospace district that in the near future hopefully can host rockets. I just focused on a project that we are presenting in Zambia, in Africa, where we are extracting from the replanting projects the carbon credits directly with our devices. So we install our CO2 detectors. We collect data from the CO2 sensors, and we collect all the data in our big data, and we can print, let's say, and grant with a third-party partner carbon credits, and we can sell directly carbon credits to a big company with an high impact on the climate change. This is a very democratization, let's say, because imagine that World Bank invest in Zambia $500 million. That is, they have to get back money for sure. But with this project, they transform a cost in a profitable asset, because with this idea, they transform the loan of 500 million in a profitable market of 3 billion. So it's quite important what we are doing with these little things. So I don't want to stall you other time, but Pongo is quite good, and you can use it like an end-to-end platform with several devices, and you can use directly your own satellite or a shared satellite. And we want to help increase the new space economy market to spread our technology to other picosat manufacturer and the new companies on the market. So we are here to help each other, and we've done I think a good path till here. And if you want to join us in this project, we are here even for you. Thank you very much.
Have you got any questions? Yes, sir.
Thanks very much. So it's quite impressive what you are doing, actually. And I just want to know, can you provide a bit more information about this technological origami sort of panel?
Yeah, for sure. We have now, as I mentioned, the path to use our flight heritage subsystems to create cubesat, new cubesat subsystem already, let's say, with a near flight heritage mode. Okay, but what we are booked for, because now the company is, as I mentioned previously with you, is booked for 60 million euros of projects. But to do that, we have to mount several new optical payloads, and we have a lot of problems with the power budget. So to do that, we work on mechanical new figures, in order to spread the enlarge the usability of the volume. So the origami approach was fantastic to use the same volume to provide a lot of surface after the deployable system done. It works. So that's it. We are testing it for the 2025. We are booked for the Transporter 13. Thank you.
Any other questions? Jeffrey?
I have two questions. For your graphite battery, did I read it correctly? It says 7,250 milliampere hour.
Yeah, it's quite a new polymer.
Yeah, no.
Yeah.
Not about the graphene, but what was the dimensions? Can you show the...
Yeah, for sure. The dimension is, let's say...
I mean, maybe you cannot show the detailed data, but do you have like the test report?
Here, no. Here in the presentation, no. But we can see together in another.
So those dimensions are for your battery, not the lithium-ion.
Yeah, for this is actually this is the volume of 2 Lion batteries.
Okay.
So it's quite as you can see here, and of course you can see here. No, we have here we have 2 plug for the batteries, and one of them will be a graphene battery for the first mission, so we can test the graphene batteries and the charge-discharge cycle in order to enable the thrusters to be hit in the correct way, because it's quite a supercapacitor. If you, okay, it's quite okay.
My second question is, in a couple of slides further, if you go forward, not back, there is the ground station that you showed the antenna.
Yeah.
What's the, can you operate for its diameter and like?
Yeah, this one.
So like, yeah, like, is this the thing that you are planning to provide, or like?
We are starting to provide the ground segments because for sure we are starting to do the democratization path in some countries like Zambia. We want to install an on-premises facility. Okay, so we want to provide S-band, UHF, and VHF band. Okay, with several modes, and we want to provide, let's say, data sovereignty approach. So it's quite important for these new countries that they don't see after years of, you know what, they want to be independent for, I think, good reasons. So to do that, we are starting to provide even Ka band ground stations. Ka band, because we are now focusing on reflectors, on cubesats, and other several projects that for us, as I mentioned, we're an ICT company. Only an ICT company. After several years now, we are an aerospace company with. We had only IoT skills, but quite good skills, I think. And now we are on this topic for these reasons.
Okay.
Thank you very much.
Okay, so see we've got 2 more. I'll go to, I think Joe has his hand up before, so.